Okay, today I'm going to talk about saws, saw blades, how they work, and cutting some pieces of metal so that you can fit up and just practice some stick welding before you actually take on a project of welding. First things first, this is a hacksaw. Hacksaws are designed to cut metal, and the reason why is because metal is a much harder material than most other common uses for saws like wood. Saws and saw blades have what's called pitch. The pitch is the amount of teeth over 1 inch. So it's called TPI, or teeth per inch. So the pitch is determined by how many teeth are over 1 inch. Teeth per inch equals the pitch. TPI equals teeth per inch. So on wood saws, the pitch is much lower than it is on metal saws. So the higher the pitch, the harder the material. So here it shows there's many more teeth over that 1 inch. More teeth over 1 inch equals a higher pitch. So where a lower pitch you would use for softer materials. And there's less teeth over 1 inch. The reason why is because the harder material, you're taking much smaller cuts. Even though they're smaller, you're making many more at one time. Whereas a lower pitch with less teeth would be used for like wood, because it can rip through the material much easier than a harder material. Now you could use the higher pitch on the softer material. It doesn't make much sense because it would take you much longer as you're taking smaller cuts. You cannot, however, use a lower pitch on a harder material because the size of the teeth will not let you make a cut in the harder material. The material would end up just getting caught inside those large gaps like a wood saw on metal. You wouldn't be able to use it. So they designed these saw blades with larger teeth to cut wood and smaller teeth to cut metal. Higher pitch, harder material. More teeth, harder material, higher pitch. Less teeth, lower pitch, softer material. And the pitch is teeth per inch. Teeth per inch. The teeth on saw blades are angled forward. So the angle on these teeth makes it so that you can only cut in one direction. This would not cut going that direction. So these little blades are actually digging into the metal or whatever material you're cutting as you're pushing forward. When you draw the saw back, it's just to get a new location for another push forward. Then you would almost lift up and pull back and then push forward again. Mechanical equipment like bandsaws and things, all the teeth are angled forward also, and the blade just keeps spinning around. So it's always going in one direction. And it's always cutting on that forward movement. So Here's the hacksaw, and I'm going to try to get a close-up so you can see what the actual blade looks like. Now you can see there's a lot of teeth over this little area. Now the reason why that you see gaps here, 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 and here, like all the way across the blade, it doesn't mean there's no teeth in that point. What that means is actually on the opposite side of the blade, there are also teeth, and where there is a gap here, it means the teeth are on the other side of the blade. This is a brand new hacksaw blade, and you can see the teeth on the bottom there. It's harder to see the gaps, but there's still gaps like this, and there's in those gaps there's teeth on the opposite side. So if you look down the edge of the saw blade like this, the teeth are also pointing out that way, and then the opposite teeth are pointing out that way. So it makes it a little wider like this at the blade than it is on this part. So this part is one thickness, but then at the blade area, there's teeth pointing up on this side, and then there's teeth pointing down on this side. That makes the cutting area of the blade, where the teeth are, a little bit wider than this part of the blade. This is so that when you're cutting through the material, it's not pinching on the material. So there's, if you can see it that way, it almost looks squiggly as you go down. That's because they stick out here on this side, and then the opposite ones stick out on this side. Then these stick out here, and then these stick out here. Then these stick out here, and these stick out here. That clears the metal chips from the cut, and it creates a little bit of a wider cut than the thickness of this, so it doesn't get pinched inside the cut. And you can see, it's hard to tell what the angle on these teeth are, and that's what the arrow on the blade is for. The teeth can get broken off very easily, especially when you're pulling back against the cut. You break those little teeth off. And after they get worn and used so much, you need to replace them. So I'm going to show you how to do that. And to replace these blades is pretty easy. There's a little hole in the blade on each end, and you just put it over that little post on the one side of the blade, and on the opposite side of the blade there's another post on the opposite side of the blade. On the back of where the blade is, there's just a little wing nut there, and you loosen it and turn it to the left, lefty-loosey, and this post that's attached to the blade will just start to loosen up and move forward. That's how you loosen the blade. So you just keep turning it until that screw moves out. And then when it's loose enough, the blade will come right off. Then you just take it off on that side as well. And that's how you remove the blade. So when you're ready to put a new blade on, it's the same thing. Look for the arrow. See the arrow? So this would be the wrong way to put it on, because the arrow means it cuts in this direction. And the saw works in this direction. So I have to make sure that this blade goes on this way. So you put the little hole over the hook at the front. Make sure that the screw part is pushed all the way forward. Once you have both ends hooked, just start tightening. And it will draw together and start getting tight. And you want it pretty tight so it doesn't move around while you're cutting. Just get it as tight as you can get it by hand. When you're cutting metal with a saw, the friction between the two pieces of metal, the blade and the piece you're cutting, that's also not good for the cut or the saw. So we have to put some kind of lubrication on the blade to reduce the friction and the heat buildup. So I have what's called cutting fluid. This is just a synthetic oil type stuff that's in a squeeze tube. And you don't have to tilt this. So you can see, all you do is squeeze and the fluid comes out of the tube. Now you don't need a lot of this stuff. You just really want to put it on the blade a little bit. Just like that. And you don't want it laying on there that much, so you can just wipe it a little. Don't wipe it all off. And then you can wipe the other side too, to put some on both sides. And as long as it looks wet, it's good. It shouldn't be dripping. It should just have a little coat of oil on it. That's all. And then you're ready to cut. So I just got myself a square piece of metal, measured out half the distance, scribed the line, and I'm gonna cut right down here with the hacksaw. And then I turned it up and made a scratch at the top on this edge, because this is the edge I'm actually going to be starting my cut on. So if you follow it up, there's a scratch at the top so I can identify where to start my blade. Whenever you put metal in a vise and you're going to be cutting it, where you cut needs to be close to the vise. As close to the vise as you can get it, without the saw interrupting, because the saw you don't want the saw to hit the vise and throw you off. So I would want to cut about there. Little bit away, not right on the vise, but just like maybe a ½ inch out. You don't want your piece of metal in the vise like this and be cutting out here. The reason is, the further away you are from the vise, the less rigid it is in the vise. And it creates a lot more vibration or chatter. You can hear the difference between that and that. The difference between those two sounds, you can tell that there's much less vibration when you're closer to the device. When you have vibration between two pieces that are cutting, you don't create a good cutting action. And in high industrial machinery, it could damage the part, it could damage the machine, and it could damage the tools. So when you're about ready to start your cut, you can put your hand on the back of the hacksaw, so you're using two hands, just to hold it steady when you make your first little cut. You just want to gently slide across the top to start a groove into the metal. And notice I'm going forward and then lifting up and coming back, then going forward again until I get a groove. Now I have a groove in the metal. Now I can switch to one hand because it's going to help me control the saw better. Or two hands on one side. If I'm trying to cut all the way through with two hands like this, it's going to force me to get out of line with the cut. If I'm out of line with the cut this way, or with the saw like this, my cut is going to go bad. It's going to come down and go on an angle. It's going to start swooping down on an angle, or it's going to not cut right. So you want to keep your saw as straight as possible in the cut. So push forward, and I'm tilted down a little bit so I get more of a cut when I'm pushing forward. Then I can just pull back, and it's actually lifting up a little when I pull back. Push forward, pull back. Now I'm really concentrating on trying to keep this saw straight this way and this way so that I don't mess up my cut. I want to keep my cut as straight as possible. Plus, not only does it keep your cut straight down, it's also easier because if I'm tilted and I'm not straight in the cut, it's going to start pinching and it's going to get caught up and be much harder for me to cut. So if you're having trouble getting through the material, it's because your saw is not straight. You should be able to gently slide right through there. So take nice, steady strokes with the saw, letting the saw do the work. Let the saw do the work. You don't need to be like super aggressive with it like this. You don't need to saw like that. That's just going to throw you off your cut. Gentle and slow, and let the saw do the work. And start listening to the tone. As I'm getting all the way through, I'm getting close to the end. Listen to the tone change from a high pitch, and it will start getting a lower pitch. It's getting lower pitched because there's less surface area now. And that's a good signal to let me know I'm getting close to getting through. So start slowing down at the end. Take slower cuts. And you'll see I'm almost all the way through. So I'm just taking nice, easy, slow cuts. And once I get, we're almost all the way through, it's gonna start falling away. That's when I can grab it with my left hand, not under the blade, but over the blade. I can grab it with my left hand and start gently sawing the rest of the way through so it doesn't fall to the ground, like that. Loosen the vise, take your scrap piece out, or your good piece, however it is that we're looking at it. And now once you're done cutting, there are heavy burrs on the edges of this metal, so be careful. There's heavy burrs all the way on both sides of the metal now that can cut you or get splinters in you, so be careful.